All right, so we're going to begin a small video series talking about dimensional models and how they're supposed to align with our business requirements. So with that, let's start talking about what is a dimensional model. And simply, it's a simple retrieval-based database that is designed for high-volume query access. And this is very important, high volume query access, because a traditional database in an organization, especially for transactions, is really meant for high volume storage. In a dimensional model, we're designing our database for retrieval, right? And so the data model for the data warehouse or data mart is going to be able to allow us to design something that's going to allow, it's going to allow us to create a schema for high volume queries. Okay. By the way, our modeling is going to be a simple entity relationship diagram that's very common in database design. We're going to be able to use this structure to be able to load data into, right, when we start creating our data warehouse, and that'll make some sense in the coming weeks. All right, so what we want to do is we want to be able to present that information that is requested by decision makers, so they can perform queries that will produce results as fast as possible. Right? We want to give them relevant information that is accurate and it's related to those business processes. So with that, let's talk about each component of our dimensional model. First is, what is a fact? Okay. Now, fact and measures tend to be a little bit confusing because in the very simplest form, a fact is nothing more than a row in a fact table. But if you've never seen a dimensional model, that might not make much sense to you. So we have this big definition that makes it more complicated, in my opinion, but facts are the measurements that result from a business process event. So if I was going to make it very simple, I would focus on this component of the definition. It's all about a business process event, like a sale. When something is sold, what is recorded? Well, in the event of a sale, you might need to know the salesperson, right? You might need to know the product. You might need to know the customer. And what you also may want to know is how many. And then also how much money was earned. Okay. So when you combine all of those together, this creates a fact. Right. Now, a measure is like what I mentioned at the last part, is how many is sold on that one particular sale and how much money was made. So this is the numerical property of a fact, and it describes something that is relevant to the analysis. Typically, it's numeric and additive. Combined, facts and measures are represented in a fact table. All right. We'll come back to this later. It's going to make more sense as we kind of go through some examples. But let's talk about what a dimension is first. A dimension provides us an idea about who, what, where, when, why, and how that business process event occurred. So earlier I mentioned salesperson, the product, the customer. These are all nouns that describe the objects that participate in that event. These are represented in dimensional tables in the database or the data warehouse. They can be hierarchical and they can be normalized. We'll make more sense of what these two terms mean shortly. Okay, so with that, when we have multiple dimensions, and a dimension, of course, can be something like a product, a salesperson, a market segment, a business unit, we could present things based on measures of money, sales, headcount, inventory, profit, actual versus forecast type of scenarios in a multidimensional view. So, for example, we can present data that is analyzed in several dimensions, such as sales by region, sales by product, sales by salesperson, and sales by time. This is 4 dimensions. This is the idea of multidimensionality, is that of all the dimensions that we could possibly have in our data warehouse and our measures, we can usually combine these that will create some type of multidimensional analysis. Now, the last thing I'm going to say is there's something special about time when it comes to our data warehouse. Typically, time on a calendar format is our dimension. However, if time is an important measure for an event, like the start of an event and the end of an event, that could also then become a measure. So don't get confused when time is a dimension versus when it is a measure. Okay, and this will become clear as we work with this more. So how does this fit together in a dimensional model? So this is a portion of an ER diagram, and this is conceptual. So some of this may not make sense at the current time. But we mentioned earlier that there's this thing called a fact table. And basically, when I'm talking about tables, I mean data tables, right? So something you might see in a spreadsheet software program. And in that, we're going to have all of the objects that are related to the business event and the measures that are related to the business event, right? So all of these combined create the fact. Now, the measures are the numerical properties. And here, if you notice, if you're familiar with databases, I'm calling this dim1 ID or dimension 1 ID, which corresponds to the dimension 1 ID over here. In the fact table, it exists as a foreign key, but in a dimension table, it exists as a primary key. That's what PK and FK stand for. However, dimensions are reserved just for nouns, like an employee, a customer, a product, a subtype of that product, a location, person, place, or thing. Typically, in a data warehouse, once you define a dimension and the attributes, an attribute of dimension for a person might be their name, their address, their city, right? For a product, it might be its description, its cost. For the location, it might be city, state, zip. Right? So these types of dimensions, once they're created, they usually don't change much. Most of the changes occur in the fact table when events are recorded. So remember what I said previously about a fact table? That facts really are more concerned about an event. Keep that in mind. All right, this diagram may be helpful for you in the days to come. All right, there's 2 main schemas that we typically design our data warehouses from, and they combine, of course, fact tables and dimensional models. We have our simple table, which is a fact table surrounded by several dimension tables. A snowflake schema is nothing more than a star schema with additional branches that create a snowflake shape. Let's kind of put this into a visual representation. So on the left is our star schema. It's very basic. Central fact table and its related dimensions. However, that snowflake also has a fact table, but the dimensions now kind of spoke off. And you see how this creates like different branches that creates somewhat of a snowflake pattern. Right? So with that, we're going to pause right here and we'll continue on in the next video.